Hey everyone, Jay here, and it's time for another Python lab. This is lab 4. We're going to be creating some variables, uh, doing some processing, and then outputting those variables. So we're talking about input, process, and output, the three of the fundamental things that computers do. We gather some input somehow, we process that input somehow, and then we output that input, that work that we did somehow, right? So some options for input is we could input from the user, or we could input from a file, we could input from some other computer program. Our program is going to gather some input one way or another, and then it's going to process that input. Could be processing with math, we could process with some logic structures that we'll learn about. We're going to process it somehow, and then when you're done processing, you have to output it somewhere. Maybe you output to user, maybe you output to a file, maybe you output to another program, right? And so that is, in a very basic nutshell, everything that computers do, right? It's always input, process, output. Um, so I have our lab instructions here. We're going to put our standard header at the top of our file with this Python shebang that pretty much should always be there, and put a little comment section that says what this file is. Again, always should be there in all of our files. Then we're going to create some variables. Okay, so instead of inputting from any of the places that I mentioned already, we're going to just declare some variables right into our program and give them some values. We're going to hard code those values in. Hard coding is when you're literally just coding values in for numbers or for variables, right? And that's because we're going to do some more input stuff later on. We're going to start slow, one step at a time. Okay, so we're just going to declare our variables right in our program. Then we're going to do a very little bit of processing, and then we will output those variables after that, right? And we're going to try and put some good comments in to our code, because comments are for future you. All right, you're in the future you'll make some bigger piece of code than this, and then it'll work great, and then you'll come back to it in a month or 6 months or whatever, and you'll have an update for it, and you'll go, who wrote this god awful mess? Oh yeah, it was me. I didn't comment anything. I don't know what's going on. I have to reread all of this and basically figure out what everything does. It's almost as much work as it was the first time you made it. You have to learn the whole process over again. What was I thinking when I wrote this? What's it doing? Right? All that stuff. So leave good comments that are for you, for future you. Okay. Um, and then another note here that I have is some things that we're not going to do is we're not going to create a variable and then output it, and create a variable and then output it. And that is very messy and ugly and difficult for future you to decipher in the future, right? So we're going to have a section of our code for all the input, a section of a code for all the processing, and a section of code down below for all the output. Now, sometimes if you're working on a more complex project, it's not quite that simple to break apart the input, the process, and the output section. You may have multiple possible outputs that get broken apart. We'll learn how to handle that type of stuff later, but for now, we're literally just going to code them in separate little sections that are separated by a little bit of space and some comments. Um, so let's have a look at that on my other, all of that, and you're looking at the wrong screen. There's the instructions. Feel free to pause and have a look at that. Oh, it's over there. All right, now let's look at my blank code. There we go. So I have my starting, I have my shebang at the top, and I have my descriptive text that tells me what this file is. Okay, it tells me the author, it tells me the class name, and it's lab 4. Okay, if you're working on a project that's not a lab, you'll have some other information there. You may have some copyright information or you'll have some other stuff. And that'll be dictated based on what you're creating and where it's going to be used. Okay. But for now, let's start making some variables. First, I'm going to make an integer variable. I'm just going to call it my int because I'm super creative. Equals 0. So integer variables, just like the name suggests, it is an integer. It's going to be all the whole numbers, positive, negative, whatever, just no decimal places. Okay. Python is more of a loosely typed language. All right, some programming languages you have to say this is going to be an integer variable and you have to give it an integer value, and if you ever accidentally make it equal to something that's not an integer, the whole computer will halt and throw errors and break. In Python and in some other languages, it's a little more loosely typed. That is, for the data type, you can assign something to be an integer, but then later we can make it a decimal, or which we're going to call a float or a floating point number, or you can make it equal to text or something later on. All right, it's a little bit more loose. All right, that with that freedom also comes responsibility. You knew that was coming, right? So we have the freedom to change the type of our variables, but we need to do so responsibly and make sure that we're not accidentally creating garbage, okay? If we take our variable 0 that I have right here and I somehow turn that into like the letter O, and then I try to do math with it, that's not going to work. All right, so we need to be responsible with our variables and make sure that just because we have this freedom to not have errors, because sometimes it's useful, especially if you're dealing with an integer or a decimal number. Like, you can do math with those, and it shouldn't be a big deal. That's kind of the purpose of this, but you need to make sure that you're not trying to do math with text or trying to do math with a date object or something, right? So let's continue on and make a floating point number equals 0.1. My instructions say a different value. That's okay. So floating point numbers are decimals, okay? Python is pretty good about doing floating point numbers correctly, but it is a computer. The way floating point numbers are saved, they're not just saved as 0.1 or whatever we type in there. That's just not how the computer saves it. It actually saves it as a binary fraction or combination of fractions. So if you put a number in there that is somehow difficult to be saved as a fraction for the computer, then sometimes you'll do some math with it, and a common one is you'll have something like 0.5, and then later on it'll spit out 0.4999999, and you're like, what's going on here? Right? That's a normal floating point error. We don't worry about them too much. We just try to plan ahead and like round numbers properly and work with integers whenever possible, things of that nature. So depending on what you're doing, you'll have a little bit different solution for that in the future. But for now, we don't have a problem here. I can add these numbers. I'm not going to get that floating point error today, okay? Because we're not doing anything super advanced or difficult. So we're just not even going to see that. If I add these two numbers, it's not going to be a problem. But just know that that can rear its head sometimes, and depending on what your goal is and what you're trying to do, you'll have to use some sort of a different solution. You can round numbers to different decimal point values. Okay, you can round numbers to 3 decimal points, 4 decimal points, whatever, right? Even 5 decimal points. You can round those numbers. That's usually a pretty good way of doing it. Alternatively, if you need something that's, let's just say you need 2 decimal places, you can multiply by 100, turn it into an integer and forget the rest of the number, and then work with integers. And then when you need to do the decimal part again, you just divide by 100 and you'll get your 2 decimal points. That's pretty bulletproof way. It does add a couple extra operations, but just give you something to think about in the future. Moving on. We'll make a text value. All right, text value can be any string of characters in text. You can use single quotes or you can use double quotes, depending on how you use them and what language you use them. The single quotes and the double quotes are very different from each other. Personally, if the language lets me use it, I like to use single quotes vastly more often than double quotes, and the reason is to do a lot of web programming, and I like to be able to put my double quotes inside my string. Okay, so I could put double quotes inside of here for some reason, right? And that will be actually inside of the text string. My quotes will be in there. If you need to put a single quote in here for any reason, you're going to have to escape that because you'll see that it really broke that. We'll talk about that more in the future. For now, we're just making text and we're outputting stuff with a little bit of processing. Okay, so we have an integer, a float, and some text. Some of you who came from other coding languages may notice I'm not putting semicolons at the end of my lines. It's Python. That's how we do it. All right, let's get my float, and we're gonna say plus equals 1. I think that's how I write that. All right, and I want to add to my integer as well, and I'm going to put it actually in front of my float, like I should have done. Plus equals 2. And then my text equals, I'm not going to concatenate today. All right, concatenate is what we call it when you put 2 strings of characters together. You don't add them together, you concatenate them. So that is just a little bit of processing, just adding numbers, right? And then I'll move down to the output, get some space here for you. And my output, I'm going to print to screen, print. And first I'm going to print my int. Then I'm going to print my float. And I'm putting a little space at the parentheses to make it more easily read by humans. Computers can read it, but humans also need to read this. So this is lab 4. Right? We've created some variables, we did some very easy processing, and then we're going to output these same variables. If I run this, fix a little typo in here. I have a little equal sign, extra equal sign typo. But let's go ahead and run this code and have a look at it. The run button is this green one up here if you're using Thonny. If you're using something else, the run button is somewhere else. Let me show you the output area of my code, and then I'll run this, and you'll see that it's just going to give me this final output. So I'm going to have my integer, the first number, starts off as 0, and then I've added 2, and then it printed it out. The next number, my float, started off as 0.1. then I added one, and then I outputted this. And the string of characters, my text, started out saying hello world, and I changed it to my name, and then it outputted that. Right? So that's it. Let me go back and show you the code again. Right? This is all of the code that we're going over today for Lab 2. If you're in my class, this is exactly what I want you to turn in over here. This is exactly what I want you to turn in, except with your name and not my name. If you turn it in with my name, you will be cheating. And you don't want to be caught cheating by turning in something that you literally should have been copying in the first place. Right? Copy exactly this, put your name instead of my name, and turn that in. All right, that's it. Thanks for watching. I'll see you in the next video.